and welcome to Science Saturday. I'm Shannon, the Program Service Coordinator at the Ingersoll Library, and today we are going to do some interesting experiments with ice and snow. So first, we need to set up 2 experiments and then put them aside because they take a little bit of time, and then we are going to do a couple more experiments all together. Are you ready? Let's get started. So the first experiment we are going to set up and then leave for a little bit is called ice observations. So for this experiment, I'm going to use a muffin tray, a bunch of ice, some tape and a marker to label, and then I have salt, sugar, olive oil, you could use vegetable oil, cold water, and then warm water. So before we start, what is ice? Do you know what ice is made out of? So ice is frozen water. So I froze the same amount of water into 6 different cups. So for an experiment, we want them to be the same amount of ice so we can better compare what happens. So I'm going to put 1 block of ice in each section of my muffin tray. We are going to test and see which one of these substances melts the ice the fastest. But to know what goes into each one, we need to do some labeling. So the label is going to let us know what we put into each so we don't get confused. So I have salt, sugar, oil, cold water, warm water, and then this one here in the center, it says control. What do you think that one's for? So the control ice, we aren't going to add anything to it. We're just going to leave it alone. It's just going to be our ice, and it's going to be our base to see how ice would melt just without anything else touching it, just in the room. So now that we have our labels, we need to add our substances. So while you're doing this, or even before, you need to make a prediction. So what is a prediction? So a prediction is what you think is going to happen. Which one do you think is going to melt the fastest? Which one do you think is going to melt the slowest? How long do you think it's going to take? A couple minutes? A couple hours? So you can make your predictions. You can also write down your predictions so you can go back and look at them later. So our salt and our sugar, they do look very similar. They're both a white grainy substance, and then we have our oil, water, control has nothing, and warm water. So now, once we made our predictions, you can watch what's going to happen, or you can just leave it off to the side and come back and visit it later. The second experiment that we need to set up is snow versus water. And for this experiment, you need a jar or some sort of container. You need to fill it with snow from outside, which we have a lot of right now. A ruler, tape and a marker, again, for labeling. And you might need a plate and some paper towel as well. We know that ice is frozen water. But what is snow? So snow is also frozen water crystals, but there's more air mixed in there, which gives it a light, fluffy texture. It can be said roughly that there's about 10 inches of snow. So 10 inches. For every 10 inches of snow, there's about 1 inch of water. So about every 25 centimeters of snow, there's about 2.5 centimeters of water. So we're going to test that out and see how much water is in this jar of snow. So I filled this with snow from outside in a snowbank. I packed it down just a little bit. It doesn't have to be super, super firm. And it looks like my snow made it to about just where my jar sort of rounds out. So I'm going to use a dry erase marker to sort of mark off. You can use a ruler, but it's tricky with a rounded container. So mark off just sort of where my snow started. And then you can measure roughly So I have roughly 17 centimeters of snow in my jar here. So you can record that on a piece of paper, or if your tape will stick to your container, you can write it right on there. With all experiments, we need to make a prediction. So how much water do you think is going to be in this container when all of that snow melts? So now that we marked it, we need to wait and watch it melt. How long do you think that's going to take? So we can wait, or we can do other experiments together. I agree. Let's do other experiments together. We'll come back and check on this. So this next experiment is called ice on a string. So I'm going to be able to pick up this ice cube from this bowl of water using this string, but not touching it with my hands. How? Let's find out. So what we need for the ice on a string experiment is a bowl of cold water, ice, a string, and some salt. So ice from an ice cube tray would work just fine as well, but I didn't have an ice cube tray, so I'm going to float my ice there and then drape my string across so it's touching my ice cube. And then you're going to sprinkle a little bit of salt on top of the string, and now we wait. And there we go. You can lift the ice cube without using my hands. So why does that work? Salt lowers the melting point of ice. So the salt melted a little tiny layer and then it refroze to the string, allowing me to be able to pick it up. Give this experiment a try. You can try it from an ice cube that's sitting on a plate. You can try it with different kinds of string and see what works for you. If you're looking for some wintry books for some home reading, check out this book, Explore Winter, 25 Great Ways to Learn About Winter. It has projects, activities, and experiments. There's also this book called Winter, Creative Activities for Young Children, full of different wintry themed craft projects that you can do from home. Or this book called Weather and the Seasons. So this has all the seasons and all different kinds of weather in it. But there's a page here all about ice and different things like that. You can also check out these books, All the Science You Need to Know by age 7, Snacks, Snooze, and Skedaddle, How Animals Get Ready for Winter, and Our Environment, Everything You Need to Know. You can find all of these great titles in our catalog at www.ocl.net. You can place a hold on those for pickup. So let's check in on our ice observations. So if you made a prediction earlier, you can see how that prediction's going. You have the option, you can change it, you can make new predictions and new observations. So what do you see happening? So looking at my tray here, it looks like the salt is melting the fastest. So you can see all that water in there. There was no water before. I only added salt, so that's all melted ice, and it's making a little crater in the top there. And we know that salt lowers the melting point of ice. So it is melting it really, really fast. I'm surprised that the sugar is melting fairly quickly. Oil doesn't really look like it's changed much. Warm water, a little bit. There's the control, so that one had nothing in it. It was just a piece of ice in the cold water. So far, my ice observations, this has been about an hour. So if you set this experiment up at home, check on yours. How's it going? How long is it taking? Are your predictions right so far? What do you observe happening? All right, so let's check on our snow versus water experiment. So quite a bit of snow has melted in that first hour. So that's where the snow was before. And it's down here now. But you can see all the snow that's melted This was full right to the edge. So it's not just melting from the top down, it's melting inwards. It's melting from all sides. And there's a tiny, tiny, tiny bit of water in the bottom. It's been about an hour. How long do you think it's going to take to melt that whole jar? If you set this experiment up at home, check on yours. So now we are going to do an experiment called wire versus ice cube. And this one takes a little bit of a setup. For this, you need to make like a bridge. So I have 2 chairs and just a piece of wood in between. You could use a tray or something. As long as these 2 surfaces are the same height, and you can make like a bridge. You need some sort of weights. So I have these 2-pound weights here that I'm going to use. But you could really use anything as long as they're the same. You could use 2-liter pop bottles full of water, whatever you got, as long as your 2 weights are the same. And then I have a piece of wire here. It's just jewelry wire, and we're going to use that in a second. You need a paper towel or a face cloth or a piece of felt, something to catch the water that's going to come off of your ice cube. Again, a regular size ice cube would work, but I made a giant one, so it's a little easier to see. So first, we need to wrap the wire around the weights. All right, so I have my 2 weights attached by a wire. If you're going to try this experiment at home, please have a big person help you. Find an adult somewhere. The wire was a lot trickier than I thought it was going to be. So ask for help, please. I'm going to put my bridge in place. In this experiment, we are going to see this wire cut all the way through the ice cube, but then the ice cube is going to stay whole. So you did hear that correctly. The wire is going to cut all the way through the center of the ice cube, but then at the end, the ice cube is still going to be in one piece. Do you think, make a prediction here, do you think the ice cube is still going to be in one piece? Do you think the wire is going to make it all the way through the ice at all? Maybe it's just going to get stuck there. That's what experiments are for. Let's see what happens. Okay, so I have my bridge, I have my ice cube, I have my paper towel to catch any water that melts, and I have my weights on a wire. So I didn't make them too long because I want them to be able to hang. I don't want them to hang or to touch my table. So let's try it. Okay, balance my weights here. We're gonna start, so my weights are dangling. Ice is in place. And now we wait. So it's been a couple minutes of our wire versus ice cube. As you can see, the wire is making its way through the ice cube very slowly. I think if you used a smaller ice cube, I have a super thick ice chunk going here. If you use a smaller one, it might go a little bit quicker, or maybe some more weight. That could be something that you change in your next experiment. But what is actually happening? So when ice gets pressurized, so that's the pressure of the wire being pulled by weights. So when ice is pushed on really, really, really hard, it melts. So really slowly, the pressure of the wire and the weights is pushing through the ice, and it's pushing downward. What is downward force called? Gravity, right. So the downward force of the weight and the wire is pushing it slowly through the ice, and it's melting it a little bit at a time. So as it melts, the wire moves a little bit farther down the ice cube. So as the wire passes through, it starts to refreeze. So right there you can see the wire has made it into the ice, and the top piece here is refrozen. So with all experiments, you could do different predictions. How long do you think this is going to take? Do you think it's going to work at all? Or how could we change it or make it different? More weight, different kind of wire, thinner ice cube. Almost. You can see how deep there the ice is already cut through. There's just a little bit of wire peeking out at the top here. But from here to there, you can see how much it has cut through already. And you can see that the paper towel is catching the melted ice, so it's catching all that water. Wire and ice update. You can't see the wire at all. So it's no longer sitting on top. It has made its way into deeper into the ice cube. Gravity and that pressure is pulling the wire through the ice, slowly melting a bit as it goes, and it is refreezing on the top. All right, our wire is about halfway through our ice block. If I were to redo this experiment, I would definitely use a smaller ice cube and some more weight. This is taking a really, really long time, but it is really interesting to watch it go and see how this actually works. Almost all the way through, if not all the way through. Let's have a look here. Oh, just a little bit. I think the wire has now gone all the way through the ice cube. It looks like it's flat on the wood there. So let's see. Oh. And there we go! So you can see the line there. You can definitely tell where the wire went through from all the pressure, but it worked! So the wire went all the way through the ice, and afterward, the ice is still in one piece. Very cool. This is very cool, no pun intended. This is like the world's slowest magic trick. You cut ice in half, and it stayed whole. So experiments are really, really fun. And while you're waiting for some of your experiments, maybe the ones that we had to set it and forget it, we can do a craft. So this is a snow dough recipe. So if going out into the snow outside isn't quite your thing, or it's a little bit too cold, you can play with snow dough. So what you need is baking soda and some shaving cream. I also have some glitter because why not add some glitter? And I'm going to use a bowl and a spoon to get my mixture started. So this is a really easy recipe and something you can play with even in the summer when there is snow outside. You can still have snow inside. So this is about 3/4 of a cup of baking soda. I'm gonna pour that into my bowl. There's no real precise measurements. It sort of just goes by feel and how you want your dough to act. And then all you do is spray in some shaving cream. I'm gonna add some glitter to make my snow dough sparkly. And I'm gonna mix it up. One really fun variation of snow dough that you can do is you can put your baking soda in the freezer. So it won't freeze solid, but it gets really, really cold and it feels just like snow. My mixture's coming together. It's a tiny bit more shaving cream. This is what I mean by there's no real precise measurements. It sort of just goes by consistency. Now I have my snow dough. And it stays together so you can mold it into shapes. Like a snow dough snowman. You can keep it in a container. It's not going to stay moist overly long, but you can always add more shaving cream or add more baking soda. But it's a really fun and really easy sensory tool for sensory play and things like that. So give that a try at home. If being outside in the cold's not your thing, try some inside snow dough. Well, it's been about 4 hours and I'm checking in on the experiments we set up earlier. As you can see, I still have snow in my jar. There is quite a bit of water now though, but there is still a chunk of snow. You can see where we started, the blue line, down to here. So I'm gonna have to leave that to see the rest of that snow melt. And for my ice observations, they're still not done either. So I still have ice in every single one of my sections, but the section that I put salt in is almost gone. If you predicted that salt would melt the fastest, I think you might be right. We did a lot of experiments with salt and learned that salt lowers the melting point of ice, so that does make sense. Thank you so much for joining me today for Science Saturday. These were some really simple, really easy, fun experiments that you can do with ice and snow. Check out some books and stay up to date with the Oxford County Library on our social media. You can find us on Facebook, Instagram, Twitter, and YouTube. You can see a whole bunch of really cool programming videos on our YouTube channel. And you stay up to date with our locations and hours and what's going on right now with OCL at our website at www.ocl.net. Take care, everybody. Until next time, bye.